In part B, we're asked to derive the relationship between the distance d and the angle theta to show this relationship holds. So to do this, what we will have to do is consider the forces that we have drawn in the previous part. So the tension force is made up of two components. It's made up of this horizontal component, let's say Ftx, and it's made up of this vertical component, let's say Fty. And according to our trigonometry here, this angle here will be theta. So what we can say is, since this ball is in equilibrium, the sum of the forces in the x and y directions have to be 0. So Fty has to be equal to Fg. And we can also say that Ftx has to be equal to the electric force. So we have to use these two equations to combine them in order to show this relationship. So Fty is going to be the main tension multiplied by the cosine of theta. This will be Ft cosine theta, and well, Fg we know is simply m times g. And for Ftx, it will be Ft sine theta multiplied, and this will be equal to the electric force, which we know is 1 over 4 pi times the permittivity multiplied by the big charge times the small charge over distance squared. So what we need to do now is rearrange these two. So what we should do is express the tension from one of these equations. So for example, from this one, we can say tension force is equal to 1 over 4 pi epsilon QD squared multiplied with 1 over sine theta. And then we can plug this in into this tension over here. So then what we can say is that 1 over 4 pi QD squared 1 over sine theta is all multiplied with cosine theta. And this is equal to mg. And well, what we need to solve for here is a distance, so we can rearrange for d squared. This will be equal to q cosine theta over 4 pi epsilon mg sine theta. And well, cosine theta over sine theta is simply 1 over tangent theta. We can take this 1 over tan, and then we can take the square root, and then we will end up with the equation that is required of us. Mg tan theta. Just like this.